Good day, my highly esteemed viewers. You are welcome back to class. As you already know, my name still remains Israel. Today's discussion, we are going to have a look at some highly selected questions from various aspects of your chemistry scheme of work or chemistry syllabus. These areas are meant to assist you in your forthcoming Neco objective questions, in your forthcoming Neco exams. However, it can also help you a lot in your theory. Just look at it very well, and as I always tell you, if you want to start watching this video, get a notebook and a biro to jot down things. Thank you and God bless you. Let's start. If you look at the question, selected questions for Neco objective 2024. The first question: how many moles of oxygen would contain 1.204 times 10 to the power of 24 molecules? And they gave us Avogadro constant as this. Instead of going through, we'll read each question and then solve it. Let's solve it in order to minimize time, so that we don't waste too much time. Now look at it. How many moles of oxygen would contain this? I already know that according to chemistry rule, 1 mole of any gas contains the Avogadro's number or Avogadro's constant, and they even helped out with it, and 0.0 times 6.0 times 10 to the power of 23. So what you now do to solve it easily, since they are asking you how many moles of oxygen will be present here, you will say 1 mole equals this, therefore S mole will be that. So let's see, we'll say 6.0 times 10 to the power of 23 equals 1 mole. Therefore, the one they gave us, 1.204 times 10 to the power of 24, will give you S mole. You cross multiply. S times 6.0 times 10 to the power of 23 is equal to 1 mole times 1.204 times 10 to the power of 24. So let's cross multiply. It will now be, okay, let's now make S the subject of formula. S will be 1 mole times 1.204 times 10 to the power of 24 over 6.0 times 10 to the power of 23. Okay, this one is 1 mole. By me looking at it, this one will cancel the remaining 10. It will now be 1 mole times 12.04 over 6.0. Let's see what it gives us. Ensure you calculate it properly. 12.04 divided by 6 give you 2.006. So approximately 2 moles. So let's see the option. The option is B. Answer equals B. So that's B for the first one. The second one, the number of atoms present. Let's clean it so that we have enough space to carry out more calculations. So let's look at the second question. The number of atoms present in 2.5 moles of a triatomic gas is equivalent to, and they told you that 1 mole is this, and say 2.5 mole. Remember, whether it's triatomic, diatomic, that's when you say triatomic containing 3 atoms in 1 molecule. We are still talking about molecule. Or diatomic containing 2 atoms in 1 molecule. Go through again what they taught you about atomicity, number of atoms present in 1 molecule of the element. That is what is atomicity. And so it's the same thing. Everything is same thing as Avogadro's number. So the question says the number of atoms present in 2.5 moles of a triatomic gas. So you say 1 mole, similar to what you just did. 1 mole of a triatomic gas is 6.0 times 10 to the power of 23. Therefore, 2.5 moles equals to S. Still cross multiply. Cross multiply, you have S times 1 mole equals 6.0 times 10 to the power of 23 times 2.5 moles. These atoms anyway. S will now be 6.0 times 10 to the power of 23 times 2.5 moles over 1 mole. Mole will cancel mole. You now have 6.0 times 10 to the power of 23 times 2.5. Let's see what it gives us. 6.0 times 10 to the power of 23 will give times 2.5, give you 1.5 times 10 to the power of 24. So one gives 1.5 times 10 to the power of 24 atoms. So let's see where it is here. 1.5. So that one is C. Answer equals C. C. So that is the question 2. Let's still clean it. Please follow it. As I said, get a notebook, a biro, and be jotting it. By doing so, it will be difficult for you to forget. So number 3. A hydrocarbon contains 14.3% hydrogen. The empirical formula of the hydrocarbon would be, remember, they just told us hydrocarbon. By definition, hydrocarbon are compounds containing hydrogen and carbon only. They must contain 2. One of them is hydrogen, the second one is carbon. And they told us hydrocarbon contains this. And they gave us one of hydrogen, meaning the other one is for carbon. And both all compounds, when you add their percentage, it must sum up to be 100. So if you have 2, you just remove this one from 100, get the one for carbon. So you now say carbon, percentage of carbon will be 100 minus 14.3, which gives, let's see what it will give us. 100 minus 14.3 give us 85.7. 85.7%. So having gotten that, you now calculate the normal method of calculating empirical formula. If you are confused with the method of calculating empirical formula, go to my other channel. Go to my previous video, just scroll through it. You'll see how to calculate empirical formula and molecular formula. Remember, to calculate empirical formula, first of all, there are three definitions. Empirical formula is the formula which gives the relative number of atoms present in one molecule of the compound. It is the simplest formula of the compound. Empirical formula can also be seen as a formula which gives the ratio in which the elements are combined in that compound. While the molecular formula has just one, it gives the exact number of atoms present in one molecule of the element. To calculate the molecular formula, you must first of all calculate the empirical formula. So in this case, they just told us to calculate empirical formula. That's what we are doing. Now you look at this. You now say percentage of, you say carbon and hydrogen. Carbon is 85.7, while hydrogen is 14.3, which they gave to us here. So we don't need this one again. But we know when you are solving physics theory, you have to leave it. So we now say carbon, hydrogen, 85.7, 14.3. The first stage, you say divide the percentage by the atomic mass. Divide percentage by atomic mass. So this one now becomes over 12 over 1. Let's divide it and see what we have. 85.7 divided by 12, because the atomic mass of carbon is 12. 7.14. You have 7.14, and this one is 14.3. So when you want to do it, you will now say divide by the smallest. Divide by the smallest. So it now becomes 7.14 over 7.14 ratio 14.3 over 7.14. It is when you have both of them now that you have the right to use ratio. Before then, there is no ratio. We have to, the reason why we have that ratio, because we are dividing by the smallest to get the mole ratio. It's when you divide both values by the same number that you can be able to write them in ratio. If you divide this by this, you have 1 ratio 14.3 divided by 7.14. 14.3 divided by 7.14 give you 2.00. So you have 1 ratio 2. Therefore, the empirical formula is CH2. Let's see the options. Number 3, CH2. So B, option B, answer equals B. So that gives the answer to that. Let's delete it and go through the last but not the least. Let's solve the last but not the last but not the least. Calculate the amounts of copper deposited if a current of 0.45 ampere flows through copper to tetrahydroxide solution for 1 hour 15 minutes. So just write it in this form. Let's dissociate it first. CuSO4 will give you Cu2 plus SO4 2 minus. You can see it. So we are not interested in this because the same mass of copper deposited now become Cu2 plus 2 electron, Cu2 plus 2 electron to give you Cu solid. So let's recopy it here. Cu2 plus 2 electron to give you Cu solid. So this one is 2 Faraday, 64 gram. This is 2 times 96500 column, and it's let's multiply it and see. 96500 times 2 give you 193. 193,000 column give you 64 gram. Give 64 gram. So what would the value you have here give you? So since we have already done this, the next thing is to continue our calculation. Now we have Q, which is the quantity of electricity. Q equals current times time, and current is 0.45. 0.45 times time is 1 hour 45 minutes. 1 hour is 60. 60 plus 15. 1 hour 15 making 75 times 75 times 60 again. That's what we have. Current times time. So that is what we have. So we now have 0.45 times 75 times 60 give you 2025 column. That's what we have. So here we have 193,000 gives 64. 2025 column give you X. So let's cross multiply. S times 193,000 column equals 64 gram times 2025 column. Good. They now say X will now be 64 gram times 2025 column over 193,000 column. Column cancel column. So let's clean this because we don't need it again. Remember, as I said before, when you are going through this video, get a notebook, start jotting. So let's see what we have. 2025 2025 times 64 give you, divide by 193,000 give you 0.6715. 0.6715, which gives you 0.672 gram. So to three significant figures. So that is, if you write in theory, if you even write your answer as 0.67, it's accepted. It's only in practical you don't dare it. That one must be three significant figures, or they mark it wrong for the final answer. So this is 0.672. You look at the answer here, 0.67. So option B is our answer. Answer equals B. My good friends, this is all we can take for this video. Again, appeal to you all, kindly subscribe if you have not been subscribing, and also share it and press the like button. God bless you. Shalom.